Okay, in this video we want to work on some important ideas of SEAMO and Southeast Asian Mathematical Olympiad, important ideas and similar problems from Harvard, MIT Math Tournament, HMMT, SMT, Stanford Math Tournament, AMC, and AME. We want to consider these three ideas in SEAMO, in sample problems, and solve related problems in these exams. Ideas in trigonometry, this idea replacement. And let me show you paper F problem 3, problem 4 and 5 in paper F had some problems. Okay, so we consider problem 3. If you want to know what are the wrong parts, feel free to send message to my WhatsApp number in the description and comments. Here, this problem of AMC related to this idea, trigonometry. This problem from Harvard, this problem from Stanford, Harvard and Stanford. We will solve paper E, we have a problem here, another problem from AMC 10A 2022. We can solve this problem from, again, paper E. Problem 4th, we will solve this about ratios, replacement, and this problem of Amy is related to that problem. Okay, let's work on first ideas in trigonometry before solving this problem. You can do this problem as homework. One, I release the solution of this. So let me tell you important ideas first. Okay, the first idea and the most basic idea is sine squared x plus cos squared x is 1 by Pythagorean theorem. We can say this and consider this unit circle. This vertical line is for sine, horizontal line is for cos. Second one is sine alpha plus beta equals sine alpha cosine beta plus cosine alpha sine beta. Memorize these formulas. Okay. Next one, third one, is cosine alpha plus beta equals cosine alpha cosine beta minus sine alpha sine beta. And here, sine 2 alpha, if we replace, it will be what? Alpha equals beta. It will be 2 sine alpha cosine alpha. And here, we can consider cosine 2 alpha is cosine squared alpha minus sine squared alpha. We can use first identity. It will be 2 cos squared alpha minus 1 or 1 minus 2 sine squared alpha. Cosine 3 alpha also is important to learn how to calculate it. You can write it as cosine alpha plus 2 alpha. It will be cosine alpha cosine 2 alpha minus sine alpha sine 2 alpha. Then cosine 2 alpha is, if you write like this, 2 cos squared alpha minus 1 minus sine alpha. Here we can write it as 2 with this formula, 2 sine alpha cos alpha. And then we can write it 2 cos cube alpha minus cos alpha. Here, minus 2 cos alpha sine squared alpha. Okay. Sine squared alpha by this formula is 1 minus cosine squared alpha. So it will be 2 cos cubed alpha minus cosine alpha minus 2 cos alpha. 1 minus cosine squared alpha. Okay. So if we simplify, minus 4 minus 2 cos, this will be plus this one, 4 cos cubed alpha minus cos alpha minus 2 cos alpha minus 3 cos alpha. Fifth identity, we work on tangent of sum of angles, sine of a plus b, and cosine of a plus b, not tangent of a plus b or alpha plus beta. This one is tangent alpha plus tangent beta, 1 minus tangent alpha tangent beta. Again, by this part, you can calculate tangent to alpha. It's easy. In terms of tangent alpha, let's call it easy. This is a problem as homework 2. Sixth idea. Next idea is related to changing product to sine. If we have cosine A times cosine B, it will be equals to 1/2 cosine A plus B plus cosine A minus B. Okay. Sine A, let's write cosine alpha, cosine beta. Sine alpha, sine beta equals 1/2 cosine alpha minus beta minus cosine alpha plus beta. And sine alpha cosine beta equals 1/2 sine alpha plus beta plus sine alpha minus beta. Okay. Changing product to sum. Now let's change sum to product. For example, we have cosine A of alpha plus cosine beta equals 2 cosine alpha plus beta over 2 cosine alpha minus beta over 2. Maybe you ask, why alpha minus beta? What not beta minus alpha? Cosine of alpha minus beta equals beta minus alpha, because cosine of negative alpha equals cosine of alpha. Here, left hand side is symmetric with respect to A and B, so here you can write alpha minus beta or beta minus alpha. Both of them are same. Sine alpha plus sine beta equals 2 sine alpha plus beta over 2 cos alpha minus beta over 2. Okay, if you have, for example, sine alpha minus, maybe, for example, someone asks you sine alpha minus sine beta. Okay, and you can calculate them with using these things. For example, let me write minus sine beta. We can write it sine alpha plus sine negative beta. Okay, because sine negative alpha is negative sine alpha. If you want to work on cosine negative of something, cosine pi minus alpha or 180 minus alpha is negative cos alpha. We should memorize these 7 parts. Now let's work on first this problem of paper F of SEAMO. There is a real root alpha from 0 to 180 for 3 sine alpha x squared minus 4 cosine all a x plus 2. Find the range of sine a. So it says there is a real root for this equation. So we can say what? We can say delta or discriminant is greater than equal to 0. Okay. Delta or discriminant is related to quadratic equation. So when we have real roots, we can say it is b squared when we have ax squared plus bx plus c equals 0. Delta or discriminant equals b squared minus 4ac. So if you apply it here, it will be this part squared minus 4 cosine a squared b squared by this formula minus 4a 3 sine a 4ac times 2. It is greater than equals 0. So it will be 16 cos squared a minus 24 sine a is greater than equals. Because here we have sine a and we know sine squared plus cosine squared is 1. Here we set the first identity. I write cos squared a as 1 minus sine squared a, because sine squared a plus cos squared a is 1. Minus 24 sine a is greater than equals 0. So we can take all things to right side. It will be 16 sine squared a. Before that, let's erase both sides by 8. It will be 2, it will be 3. So if we take it to right side, negative 2 sine squared a will be 2 sine squared a. Minus 3 sine a will be plus 3 sine a. 2, it will be negative 2. Okay? Now, this is a quadratic equation in terms of sine a. We know it should be negative. This quadratic equation opens up We want to find these two roots between them. This equation, this term is less than 0. So how can we calculate the roots? By quadratic equation, quadratic formula. If we apply quadratic formula, if we have ax squared plus bx plus c equals 0, then x equals negative b plus minus square root of delta or b squared minus 4ac all over 2a. And when a is positive, this graph opens up. Okay. So sine a, the roots equals negative 3, negative b, plus minus square root of 3 squared 9, minus 4 times 2 times negative 2. It will be 4 times 2, 8, 2, 16. All over 2 times 2, which is 4. So it will be negative 3 plus minus 5 over 4. So negative 3 minus 5, negative 8 over 4, negative 2. Negative 3 plus 5, 2, 2 over 4, 1 over 2. So 1 root here is 1 over 2, 1 root here is negative 2. And sine should be here. We know sine always is greater than negative, greater than equal negative 1 in general. So this part doesn't have any limitation, but we should pay attention. Sine A should be less than or equal 1/2. But because the problem says what? Says sine A is from alpha is from 0 to 180. So we have these parts. And I said vertical line related to sine. So sine from this part, sine alpha is at least 0, at most 1. And when we consider with this condition, we will see that sine A is at most 1/2, at least 0. So which of them is correct? A or B or C or D or E? A. Okay, let's solve next problem. This problem, as I said, is in AMC. I released the full solutions of AMC 12A 2022. You can do that as homework 1. Now let's solve this Harvard problem. HMMT 2023 course. Suppose x is real number such that sine of 1 plus cos squared x plus sine to the fourth x, or sine x to the fourth equals 13 over 14. Compute cosine 1 plus sine squared x plus cos x to the fourth. Let's first pay attention to these terms. We know sine of something. We want to find cosine of something. Okay? So, here they are similar. So let's consider it is alpha, it is beta. Okay? Alpha is 1 plus cos squared x plus sine to the fourth, sine x to the fourth. Beta is 1 plus sine squared x plus cos x to the fourth. Okay. When these two equations are similar equations, when we have similar equations, the idea is what? It's so much useful. We should subtract. Alpha minus beta, 1 and 1 will be cancelled, cos squared x minus sine squared x plus sine to the fourth x minus cos to the fourth. Okay, let's factor it. So it is equal to cos. Let's do something. Let's write this one first. Cos squared x minus sine squared x. I want to use a famous identity. It is what? A squared minus b squared is a minus b times a plus. Here I write sine squared x minus cos squared x times sine squared x plus cos squared x. Okay. By the identity here we said the first, the most important identity is the result of Pythagorean theorem. This is 1. So this one is 1. So it will be what? Cos squared x minus sine squared x. This times 1 will be plus sine squared x minus cos squared x. This will be cancelled. This one will be cancelled. It will be 0. So we can conclude alpha equals beta. So the problem changes to what? Sine alpha is 13 over 14. Sine alpha is 13 over 14. And now the problem wants cos alpha, because we said cos alpha equals beta. Okay, again, if we use this identity that their square is 1, so we know cos squared alpha plus sine squared alpha equals 1. And We know cos squared alpha equals 1 minus sine squared alpha. It is equal to 1 minus 13 over 14 whole squared, which is equal to 14 squared, 196, 196 minus 13 squared, 160. Will be 127. Okay. 27 over 196. So we can conclude cosine alpha is plus minus 3 root 3 over 14. Okay, now here we should see it is plus or minus. Again, we consider unit circle and it is cosine. So if we are here, cosine is positive. If here, cosine is negative. We should work on alpha. Alpha is what? 1 plus cos squared x plus sine square sine to the 4. Alpha is 1 plus cos squared x plus sine x to the 4. Now, because we have relationship, we can say cos squared x equals y. Let's see, cos squared x. Yeah, look, you can calculate this. We proved alpha equals beta, both of them. So we should consider one of them. I consider cos squared equals y, so it will be 1 plus y. Sine to the 4 is what? Is sine squared x squared. So it will be 1 plus y plus 1 minus cosine squared x squared. So it will be 1 plus y plus 1 minus y whole squared. And if you expand, it will be 1 plus y plus 1 minus 2y plus y squared. And it will be y squared minus 2y plus y minus y plus 2. And we know y cos squared x is from 0 to at least 0, at most 1. Because cos is from negative 1 to 1, so cos squared x can be this. Now, this part is a graph like this. If you want to find turning point, we should take derivative to y minus 1, 0, or y equals 1 half. So this part equals 1 half. Now, when it is 1 half, y coordinate is what? 1 half. Squared minus 1 half plus 2. So it will be 1 over 4 minus 1 half plus 2. So it will be what? It will be 4 plus 2, 6. Sorry, common denominator 4. 1 minus 2 plus 4 times 2, 8. 8 minus 2, 6 plus 1, 7. 7 over 4. Okay. Now we know it is from 0 to 1. So 0 to 1 will reach same value. 0 will be what? Will be 2. If we replace 1, also 1 minus 1, it will be 2. So we can understand what? We can understand because cos squared x is from 0 to 1. Alpha is from what to what? It is 0. It is 1. Alpha is from 7 over 4 and 2. Now we should see 7 over 4 and 2 will be what? Here it is what? Pi over 2, which is 3, 1, 4 over 2 around this, which is 1 point something. Here it is what? 1 point, let me tell you, 3/4, 75. So it is 1 point what? 11, it's 5 and something. So here it is what? It is pi. Pi is what? 3.14. So we can understand that our answer alpha is here. And as you can see, in this case, cosine alpha will be negative because it is here. So our answer is cosine alpha equal to negative 3 root 3 over 14. So we've solved this problem of HMFG. If you had question or wanted to learn important ideas like these, feel free to send a message to my WhatsApp number in the description and comments. Next problem. 2023 SMT Stanford Math Tournament. Compute the number of values of x in the interval negative 11 pi to negative 2 pi that satisfies this. So let's work on this approach. Here you should pay attention to 5 cosine x plus 4 is 0. Numerator and denominator shouldn't be 0. 5 sine x plus 3 shouldn't be 0. So if we consider this, let's first consider bad cases. If 5 sine x plus 3 equal to 0, from here, so let me do something. From this part, we can conclude cosine x is what? Negative 4 over 5, okay? From this part, we can conclude what? Sine x shouldn't be equal to negative 3 over 5, okay? Now, we can consider unit circle, we can consider the diagram. Let's consider unit circle first. This one, this one. Okay. Now we want to see, can these things happen simultaneously? Yes, because cosine squared is 16 over 25, it's 9 over 25, it happens. So we should see under what condition. So when we start from here, cosine x is negative 4 over 5. Negative 4 over 5 will be near negative 1. It will be a point like this, okay? In this point, cosine is negative 4 over 5. In these 2 points. But one of them is bad because sine x, look, we know when cosine x is negative 4 over 5, then sine x is what? Because we know sine x squared is 1 minus cosine squared x is 1 minus negative 4 over 5 squared, which is 1 minus 16 over 25, which is 25 minus 16 over 25, which is 9 over 25. And we can conclude what? Sine x equals, we take square root plus minus 3 over 5. So plus 3 over 5 is good, minus 3 over 5 is bad. In which of them sine is negative? Sine is here. So this part is bad because it is negative 3 over 5 and this part is good. So we have one angle like this. Now it says consider from negative 11 pi to negative 2 pi. Okay. From negative 11 pi, let me write the answer. From negative 11 pi to negative 9 pi. It is a whole 360 degree. We have only one answer, okay? One answer. From negative 9 pi to negative 7 pi, again 2 pi, one answer. To negative 5 pi, we know we have one answer. To negative 3 pi, we have one answer. Now we should consider from negative 3 pi to negative 2 pi. And negative 2 pi is equivalent to 0, okay? Negative 3 pi is what is here, pi. But it says from negative 3 pi to negative 2 pi. So here when it is 0, when you start from here, it's negative pi. You go here, you will reach negative 2 pi. And for this part, negative 3 pi. So here we don't have any answer. So 1, 2, 3, 4. Okay, so 1, 2, 3, 4. The answer, the problem says find the number of answers, 4 answers. So we solved trigonometric problems from Harvard and Stanford. Okay, let's work on paper E, this problem. And then this problem is similar to this problem. Again, we have some numbers like this. You can try this one as homework 3. But let's solve this problem of SEAMO. Okay, it says let 37 ABC be a 5-digit number such that this ABC, then BCA is 37, 37 CAB. It is CAB, and if you also see the solution, it was right, CAB. Okay. Can be divided by 37. How many such 5-digit numbers are there? Okay. So when we have 37 ABC and it is multiple of 37, we can write it as 37,000 plus ABC. Okay. And mod 37, it is ABC. Also, we can do this for others, so we can conclude that ABC, BCA, and CAB are multiples of, or can be divided by 37, are multiples of 37. So let's use modular congruency. If ABC is multiple of 37, so ABC is 0 mod 37. So we can conclude it is what? It is 100A plus 10B plus C is congruent to 0 mod 37. Now I use replacement. I replace C in terms of in next idea, in next problem, we also want to use replacement. C is negative 10B minus 1000A. And then we know 111 is 0 mod 37, it is 3 times 37. So it is negative 10B. 111 minus this is plus 11A. Okay, it is this, mod 37. Now if we check next number, for example, BCA, let's see, I can say what. Suppose BCA, only ABC is multiple of 37. I want to prove this one will be also multiple of 37. Let's see why. BCA is what? Is 100B plus 10C plus A. It will be 100, as you can see, it's negative 11, because 111 is multiple of 37. It's negative 11B plus 10C plus A. C is what? Is negative 10B plus 11A. Negative 11B plus 10 times negative 10B plus 11A plus A. And if you simplify, it will be negative 11B minus 100B plus 110A plus A is negative 111B plus 111A. So 111 is multiple of 37. Both of them are multiple of 37. So it will be multiple of 37. So we proved what? When 37 divides ABC, then 37 divides BCA and CAB. So the only thing we should focus on is how many multiples of 37 do we have? A can be 0, B can be 0, C can be 0, because this number is 5-digit number. So ABC is a number that is at least 0 and at most 999. So if you want to find multiples of 37, so 999 over 37, because of this 0 plus 1. Okay, if you want to find from 1 to n how many multiples of A are there, A divides them, the number of them is n over A, floor of that. So here is floor of that. Means you should round down. So here is 9 times 111 over 37. Plus 1. 37, this one, 3. 9 times 3, 27. Floor of 27 is 27 plus 1, 28. So our answer for this problem is 28. If you want to solve similar problem, try this one. And if you had any question or wanted to learn more things, as I said before, feel free to send message to my WhatsApp number in the description comments. Now, let's solve this problem. It says, okay, strawberries cost $8 per kilogram, and while blueberries cost $10, they are mixed in ratio m over n. The cost of strawberries is decreased by 15%, and the cost of blueberries is increased by 10%. However, the cost of the mixture remains unchanged. Find m over n. So here I consider two boxes. The mixture. At first, we know, for example, we have m or 8m, the price for first one, and 10n. Then first one, it says what? Decrease by 15%. So 8m times 1 minus 15%. And next one is what? 10% increased. So 10n times 1 plus 10%. And it says now the price again is same. Remains unchanged. So 8m plus 10n equals 8m. 1 minus 15%. Instead of 15%, we can write 0.15 plus 10n times 1 plus 0.1. Okay. Look, when we simplify 8m plus 10n equals 8m, we multiply minus. 8 times 15 is 120, it's 1.2 m plus 10n times 110n minus this minus m and plus m. So 8m will be cancelled, 10n will be cancelled. We take 1.2 m here and n here. Now m over n will be what? 1 over 1.2. 1 over 1.2 is what? Is 1 over 12 over 10. So it is 10 over 12. If we divide by 2, 5 over 6. So the ratio is 5 over 6. We don't have 5 over 6. So the answer is E. Now next one, this problem, how many homeworks do we have? Homework 3. I released the full solutions of AME 2 2023. You can do this one as homework 4 as a replacement problem. Okay, here, for example, you should calculate, you should find m in terms of n. Sometimes you should calculate something in terms of something, x in terms of y. And also there are similar equations you can subtract. Okay, if you had any question or wanted to learn more ideas, wanted to solve more homeworks, as I said before, feel free to send message to my WhatsApp number in the description comments. Thank you.